The epoxide can be open because there are ring constraints there. So I'm not saying that they are not unstable. Epoxide has a limited stability because it was a good shelf life too, as long as you keep it sealed. I mean, you probably heard that the epoxy glue somewhere, right? Very strong glue is an epoxy glue. I mean, industry people, they use epoxide as a glue there, two tubes together. And when the epoxide get open and makes a covalent linkage between the two together, put it together. It's very strong, obviously. But anyway, how to open the epoxide can be done in two different ways. One, the acid catalyzed way, which we talked about first, was basically adding, acid and then some kind of weak liquefier, like water, it could be alcohol, it could be something very weak liquefier, so it doesn't get protonated. So what happened was the oxygen of the epoxide get protonated. Then certainly the electron deficient oxygen is going to pull the density from the 2 carbon bond. And then the same thing, the more substituted side gets more electron deficient, and that's where the waters or the weak liquefier makes an attack. And then the water basically sits on the more substituted side. And then the epoxy oxygen goes to the less substituted side. That's the marker of products. If you happen to do that. Anyway, so this is an acid catalyzed opening of the epoxide with acidic water, but it can be done in acidic alcohol, right? You cannot just use a strong base, liquefier or basic because that's very acidic conditions. But if you have a strong liquefier, like a vineyard or organolithium and things like that, then you don't need protonation. Actually, you shouldn't protonate. If you have a acid mixed in the vineyard or anything like that, they basically kill each other, right? So that's why if you're using a strong nucleophilic reagent there, then you're never going to use a proton. So then it's going to be simply just a nucleophilic attack. That nucleophilic attack, you should remember that it's very sensitive to the static hindrance, like an acid-2 reactions. So if this epoxide is not symmetrically substituted, more substituted side, less substituted side, the nucleophile go to the less substituted side because of that static hindrance there. So nucleophile makes an attack there, opens it up. Then you got the nucleophile sitting on the less substituted side. The more substituted side gets an alcohol there that oxygens from the epoxide. So it does get open differently depending on what you do. That's going to land nucleophile in different conditions. If you're using an acidic condition, nucleophile, the water, goes to the more substituted side. If you do it in the nucleophilic condition, nucleophiles go to the less substituted side.